Hey guys, hoping all is well with everybody. In this video, we're going to be introducing Chapter 2 Geology Exam Review. What I'm going to be doing is breaking this into two parts. The first video is going to be definition core recap as well as identification. The second video is going to focus more on explanations as well as applications. So without further ado, let's look at some key definition review. The first is geology. So remember, geology is the study of Earth. Geo meaning earth, logi meaning study of. Transition zone. So transition by definition means to change or become different in state, position, or place. So transition zone is going to tell us under the Earth's surface the area from where we go from the upper mantle to the lower mantle. Okay. Core mantle boundary. Now, this is kind of the same idea of the transition zone, but with kind of a different name. And more specifically, it's not a zone. It's located at a particular point in the Earth's underneath the Earth's surface at 2891 kilometers, and it is the separation boundary between the lower mantle and the outer core. This is very important because the lower mantle is going to be solid and the outer core is going to be liquid. This is important because remember how we talked about S waves not being able to penetrate through liquids, and that means that the S waves or secondary waves are not going to be able to penetrate through the Earth's core. Okay. Next we have the lithosphere. The lithosphere is going to be that accumulation or the combination of the crust and upper mantle, defined as those two layers put together make the lithosphere. Next we have Pangea. So Pangea again kind of goes back to this idea of the plate tectonic theory. So in 1859 when we talked about those 8 large plates that interact over the Earth's crust and upper mantle, we have this supercontinent called Pangea. So these continents that we have today were not all once dispersed. That's the result of the interactions of these plates that move around over the course of time. And at one point, they were all one big supercontinent, interconnected. And that's the idea of Pangea. Next we have Sinclair and Anticline. So remember when we talked about the process of folding, when we have and are exerting a great force on an object, if it's otherwise an immovable object, it has to go somewhere. So this process of folding is going to be the result of great force on a rock. So the rock can either go in an anticline, which is the arch formation, or it can go in the syncline, which is the dip or trough-like formation. One way that you can remember this is if you draw a circle and you put anticline following the circle on the top and syncline on the bottom, you're going to see that the anticline word, it goes in an arch, where the syncline goes in a trough. Okay, again, so the syncline is going to be where the folding makes that trough-like rock formation, and the anticline is going to form that arch formation. Okay. Volcanic mountain versus dome mountain. So these two mountains are different based upon how they are formed. A volcanic mountain is a mountain that starts as a crack in the earth called a volcanic vent, as opposed to a dome mountain, which is formed from when you have flat sedimentary rock that is bowed or warped upward into a dome shape. Okay, so the differences are based upon their formation, one from a volcanic vent, one from flat sedimentary rock. Alright. Next we have a tectonic earthquake, and a tectonic earthquake is caused or induced by the movement, whether it be injection or withdrawal, of magma. And this magma is under a lot of stress, so the way that it kind of creates a pressure change due to this stress is going to cause an earthquake. Remember, due to these pressure changes, and that's again due to the stress on the magma. Okay, So again, remember, magma is inside the volcano, and as this magma is under a lot of stress from, external factors, we have a lot of pressure changes that can occur, and that's where this tectonic earthquake can also take place. Next, we have tremors. So tremors are just weak earthquakes. So think of it as like someone gently shaking you, as opposed to like someone like really like crazily shaking you to the point where you like lose your balance and fall on the ground. Okay. Next, we have aftershocks. So aftershocks, again, I kind of compared this to thunderstorms. I know it's different kind of weather or natural disaster related, but when we think of thunderstorms, a thunderstorm just doesn't stop like that. It kind of dissipates as it moves farther and farther away. We're kind of looking at it the same way. Earthquakes can't just stop like that. There's going to be an aftermath vibration, okay, of weaker or tremors or smaller earthquakes. Okay. So aftershocks are those smaller tremors and earthquakes that are after a larger, more significant earthquake. Seismology is the study of earthquakes. So seismo meaning earthquake, logi meaning study of. Next we have focus and epicenter. So these two again go hand in hand. If we look at a picture of a fault line and we find the focus of where the focus is defined as a point at which an earthquake begins, the epicenter is going to be the area on the Earth's surface that is directly above the focus. So you have the focus being the point where an earthquake begins, the epicenter being the point on the Earth's surface directly above that. Okay. Next we have a volcano, and a volcano is defined as an opening in the Earth's surface through which hot gases, ash, and molten rock are ejected from the Earth's interior. Okay, so then we do have a lot of main parts of a volcano. So we have the vent, which is the central kind of feature that is where all the ejecta comes out from. And then you have your eruption cloud, your pyroclastic flow, and other main parts. Okay, remember with volcanoes, the most important thing to remember is the difference between magma and lava. Magma is inside the volcano, where lava is the ejecta that is outside of the volcano. Okay, that's one of the critical points. Let's look at magma. So again, magma is defined as the molten rock that is found inside of a volcano that has not been yet ejected. Next we have the ejecta, which is the material substances like the pyroclasts and the volcanic ash and other parts that have been ejected or released from a volcano's vent. Okay. Next we have two different types of lava. We have Pohoho lava and AA lava. So remember, the Pohoho lava is when it is ejected out of the volcano. And think of this kind of like a gardening hoe. So gardening hoes kind of smooth out the soil. So think of Pohoho as very smooth, kind of layered lava, as opposed to AA lava, which is very kind of stationary and it's very jagged. Okay, so AA lava kind of comes into like block or irregular shape kind of lava, very rigid and irregular. Okay. Next, we're going to be looking at pyroclastic flow, and I'm going to recall the definition that it is the superheated cloud of gas and volcanic ash that travels quickly down the volcano as an avalanche. So when we're looking at certain pyroclasts, there is going to be parts like volcanic ash that have mass. It's about 8/100ths of an inch, but it's still going to have mass, and it's going to quickly go down the mountainside or the volcano side as an avalanche-based rate or speed. Okay. Next, we're going to look at the next definition, which is going to be caldera. So caldera is defined as a huge volcanic crater by a major eruption causing a collapse of the mouth of the volcano. So when a huge kind of volcano occurs, the mouth of the volcano itself is going to collapse, making a huge kind of crater. And that's basically what a caldera is. So the mouth of the volcano is here, and when it erupts, it's going to create kind of a crater as all of the ejecta kind of comes out after a big, large eruption. Next, we have a lava tunnel. It's kind of sounds it's defined basically how it sounds. A lava tunnel is a natural tunnel within solidified lava flow occupied by flowing lava. Okay. And then last but not least, we have igneous intrusion. So igneous intrusion is formed when magma is trapped beneath the surface of the earth and it pushes rock up into a dome shape. So if there's magma that is trapped under the ground, it's going to kind of intrude into the earth's surface and make that formation of rock into a dome shape. Okay? Now let's spend a couple of moments talking about some identification. So what is the most abundant element in the Earth's crust? And again, that's oxygen. So remember, we talked about oxygen being not only the necessary element for us to breathe and have a lot of life-supporting processes, but it's the most abundant element in Earth's crust from a geological standpoint. Identify the three major kinds of faults. So our three major different kinds of faults are normal, reverse, and strike slip faults. So normal forms when hanging walls drop down, reverse form when hanging walls move up, and strike slip faults are going to be walls that move side to side, not up and down. Okay? Let's look at the next question. The well-known fault in Western California, that's going to be the San Andreas Fault. And remember that that's going to be about a 1,200 kilometer fault line, or a fault, and right next to it is SAFID, or very close to it is SAFID, the San Andreas Fault Observatory at Depth, which is where a lot of studies of, using seismographs and other kind of measuring devices to really study the behavior of earthquakes. The three types of earthquake waves from fastest to slowest. So you have your fastest is going to be your primary waves, your second fastest or your next fastest is going to be your secondary waves, although they do move quite slow, and then you have your surface waves being the slowest. So remember, primary are going to be those waves that can go through both liquids and solids, and they're fast. The secondary waves are going to be slow moving, and they can only go through solids. And then the surface waves are going to be the kind of combination of when P and S waves hit the surface of the Earth and generate that third type of wave. See, the three types of volcanoes are going to be your composite volcanoes, you're going to have your cinder cone volcanoes, and your shield volcanoes. So composite volcanoes are going to be layers of both cinder and lava kind of alternating. Your shield volcano is going to be a lot of lava as opposed to volcanic ash and other kind of pyroclasts. So it's going to be focusing on a lot of fluidity in lava. And then your cinder cone volcano is going to be a lot of volcanic ash and rock fragments. The belt where over half of the world's active volcanoes are found is going to be the Ring of Fire. And then last but not least, the igneous intrusion, similar to but larger than laccolith, is going to be batholith. It is significantly larger than that kind of igneous intrusion. Alright, so this is part 1 of our Chapter 2 Geology exam review. I hope this helps you guys out. If you guys have any questions about any of the diagrams or topics that we covered or definitions, please don't hesitate to reach out and ask me. I'd be more than happy to answer those questions for you. But I hope you guys have a great rest of your day. Thank you so much for watching. Take good care of yourselves. Bye.